Alright, here we go with section 2.3, drawing conclusions. The objective for this section is to follow a 5-step procedure to draw logical conclusions. We're going to be working in class on page 74 to 75, 1 through 14. Now, by working your way through this section, hopefully proof will become very, very clear as we start moving into much larger problems. Alright, so we have our procedure for drawing conclusions. And remember, this is going to be a 5-step procedure. So step 1, you have to have the theorems and postulates memorized. That's a given. And so far we've had a few already. Second step, look for key words and symbols in the given, such as the symbol for perpendicular, congruency, things of that sort. Step 3, apply keywords and symbols. So what does it mean to be a right angle? What does it mean to be congruent? What does a bisector do? Things of that sort. Fourth, decide which theorem or postulates are appropriate to use. So moving forward, what would be applicable? In step 5, draw conclusions and justify them. Your justifications need to be based on prior steps. Alright, here we go with example 1. We're given that ray BA bisects angle YBD. So what conclusions can you make and why? So let's look at that given again. Our key word in our given is bisect. And what does it mean to bisect? Well, bisecting means that there are two congruent angles, because by its definition, that's what a bisector does. Now, for those of us that are visual learners, let's copy down our drawing here. We have our big angle, and I'm going to highlight that, angle YBD. And then we have our ray that's bisecting it. It's ray BA. Now that's creating two congruent angles. So where do we see them? Right here and right there. Now, those two congruent angles that we have, it's angle YBA, which is congruent to angle ABD. Now, our justification has to come from that given, from a prior step. What's happening? We have a ray bisecting our angle. What does that mean? Two congruent angles. So let's word it nicely. If a ray bisects an angle, it divides the angle into two congruent angles. Alright, example 2. We're given that angle A is a right angle and angle B is a right angle. So what's our conclusion going to be and why? So, what do I notice? What keywords do I have for my givens? I have right angle written down twice. When I see that I have two things written down exactly the same twice, I know those angles are going to be congruent. I got two congruent angles. Why? Because they're both right. So let's name what they are. Angle A would be congruent to angle B. And this is actually one of the theorems that we had to memorize. Our theorem stated that if two angles are right angles, then they are congruent. Alright, our example 3. There's a lot of boxes on example 3, so let's see what we got here. Example 3, for our given statement. Line BE bisects segment CD at L. What conclusions can be made and why? Now, first thing we have to ask ourselves about this is which one is bisecting. The easiest thing I can usually say to do is replace that word bisects, which is our key word, meaning creating two congruent, with the word cuts. So if BE cuts CD, which segment is being cut? It's the CD segment. Now, what conclusion can be made? Well, based off that key word, we know we're going to have two congruent segments. Why? Because by its definition, that's what a bisector does. Now, again, for those of us that are visual learners, let's copy down this picture. We talked about this. If BE is the one that's actually going to do the cutting, it's cutting the CD. That means CD is being cut into these two congruent pieces. So what are those two congruent pieces? It's CL and LD. Now, let's think about how to word our justification. We had that keyword bisect. We have a line that's bisecting a segment. And what does that mean for us? It means for us that we have two congruent segments. So let's go ahead and word that. If a line bisects a segment, then it divides the segment into two congruent segments. Alright, here's our last one, so I want you to think about this. ABC is a right angle. What conclusions can you make and why? And I want you to think, are there any other conclusions you can make? Let's press pause. Let's write down some things that we can think of, and let's check back. Alright, so here we go. First thing that I can come up with, we got 90-degree angles. Beautiful. What's our 90-degree angle? It's angle ABC. Angle ABC is 90 degrees. And the reason is because we knew that it was a right angle. Right angle was our key word. And when we know that things are going to be a right angle, we know they're 90. So if an angle is a right angle, so it came from a previous statement, then it measures 90. Now, come up with anything else besides that we had a 90-degree angle. Well, here's what I came up with. In section 2.1, we talked about some special symbol, perpendicular lines. So, which lines we got that are going to be perpendicular? I guess technically we got rays here. So what do we got? Alright, so here we go. We have that AB is perpendicular to BC. If two segments form a right angle, then they are perpendicular. So that's something else. Now, where am I going with this? Well, sometimes when we see given statements, we're going to have more than one thing that can pop into our mind. So we're going to end up needing to look at the end result of these. What are we trying to prove? And what would be most beneficial in order to prove what we need? So let's think about that moving forward, as this is kind of a crucial step. In the next few sections, you'll see that we start developing our proof and our logical thinking. The proofs are going to get more difficult. They're going to get longer. They're going to require the knowledge of more definitions and more theorems and postulates. So let's make sure that as we go through theorems and postulates, put a little star by them or highlight them, but make sure you pay special attention to them. Because in the next few sections, you'll see we're going to be adding a lot more onto the mix.